So just like before, when we worked with linear regression, that was something that was like y is equal to mx little 1 plus b. We used Desmos to go and find the specific m value and b value based on some set of tables. So for example, for the linear regression, we had a table. We need to have a table. So suppose I had a table of these points. -2, -1, 0, 1. 3, 7, 11, and 15, right? What you would do is you would use the regression. You would use the regression for x1, y1 in Desmos by entering this equation. y1 squiggle mx1 plus b. And what that would do is it would give us this specific command here, would give us the m and the b from our basic equation. Now, once we got the m and the b, we could state the regression. So you might have y is equal to 4x plus 11 as our equation. And you would say the regression is and that would be your solution. Now we're going to apply the same kind of work to this basic equation. Now this basic equation is the quadratic. There's the quadratic equation for a line. I want you to remember that that's something that you have to put to memory. So let's go and use the regression for each of these things here. The following chart contains the height of a basketball versus the distance it travels during one bounce. Now, basically, this chart here is all you have to put into Desmos. We'll take that, we'll call this our x value and this our y value, because we can control the distance that we use, but we can't control the height the ball will rebound at. So let us do that right now. So you're going to go into Desmos and you're going to create a table by clicking the plus sign and then selecting table. And then you're going to have your x1, y1, and then we're going to fill in the information from our table. So once you've entered all the information for our points, you'll notice that we have something that looks like a parabola here. Now, in order to get our parabola, get the equation of our parabola, we have to use this basic equation that we were studying before. I told you that you needed to remember y is equal to ax minus h squared plus k. Now, when we do the regression, you're going to end up with the A, H, and K for this equation, and then you will restate the equation. Now, just like before, we're going to end up having to use the Desmos equivalent of regression by using the tilde sign. And we're going to use A, x sub 1 plus minus h squared plus k. And you'll notice we end up with three different values. One for A, one for H, one for K. So now when we do the regression for y1, regression A bracket x1 minus h squared plus k, we end up with A is equal to 0.311124, H is 3, and K is that. So what we're going to do is we're going to use our A value to 2 decimal places, and the H value is already fine, and the K value will go to 2 decimal places. And we'll do that every time we do these problems. So now, let's write our equation. So we're going to get, remember our basic equation is y is equal to A, x minus h squared plus k. So we're going to use this. Y is equal to negative 0.31 x minus 3 squared plus 4.79. Now, using this equation, you know that y is the height. Okay? And if you wanted to do this, you could do, if you wanted to find out what the height was, determine the height at a distance of 7. So if the distance is 7, that's x. And all we're going to do is we're just going to substitute in. Let me just write at x equals 7, y is equal to negative 0.31, 7 minus 3 squared, plus 4.79. Negative 0.31 times 4 squared plus 4.79. And we end up with y equaling negative 0.17. So now what I want you to do is I want you to do the same calculation but at x equals 8. So tell me what you get. Now, you should get approximately y is equal to 4.01 meters. So, do that. Now, make sure you do the substitution. Make sure you do the substitution that I showed you before, and then you're good to go. Now, for these problems here, you'll notice that it says that the height is 3 and it also could be 4. So what you would do algebraically is you would do something similar to what this was, except you would let 3 at y equals 3, you get this. Actually, you know what? We'll skip this. We won't do that. So what we'll do is we'll use the regression. So what you're going to do is you're going to find out where the height is 3, and you're going to use the regression that you have on Desmos to find what you're looking for. So now, let's do that. So we need to find out what our height is at 3. So we'll go to our Desmos and we take a look at our height is 3, and if we click on here, it tells us that our x value is 0.61. But it's also 5.4. So at x equals 3, at y equals 3, x equals 0.61, and because it's a parabola, we end up with x is equal to also 5.4 meters. And we can do the same calculation for 4. So at y equals 4, we're going to check to see what we have on Desmos. So what we have on Desmos at y is 4 is we have at y is 4, we have approximately 1.4, and we also have 4.0. Okay, now moving on to the next problem here. So a bird dives from 16 meters and enters the water 2 meters from the boat and 4 meters from the boat, and exits 4 meters from the boat. So what we have is a picture that kind of looks like this. So a bird dives from 16 meters and enters the water 2 meters from the boat and exits 4 meters from the boat. But it starts at 16 meters and 2 meters from the boat. So it starts at 16 meters, flies down, and then zips out. So that looks like a parabola, right? So these are specific points. So we got 0, 16. We have 2, 0. And then we also have 4, 0 for our points. Now what I'd like you to do is I'd like you to work through this by using the regression. You have 3 points, so you're going to use ax minus h squared plus k. So I want you to do that. Work through this problem, then I want you to do the homework on your own. I'll put a solution to this as part of your work for the day.